actually discussing the physical design in the VLSI automation. We have discussed about the design rules, and we have completed that design rules. We are going with the module 2 from your syllabus, and the second topic we have, that is partitioning. So we are actually discussing, first I have told you the very basic analogy between the partitioning, floor planning, placement, what is the requirement, okay, and the analogy with the building. If you are building your own house, then just partitioning your bedroom, dining room, kitchen, and hall, those things, and placing properly to get the maximized usage or maximized area is a requirement mainly. And the other thing for VLSI design circuit, the delay should be minimized. Okay, the delay should be minimized. And how the delay should be minimized? That if we are getting the minimum cut line means minimum intersection, then there will be a reduced delay as well. So to get that thing, these all are optimization problems. Okay, we are having plenty of options for choosing, and we have to choose or optimize the best option. That is why we need all those algorithms. And I have discussed the very basic knowledge of partitioning. What is partitioning? Why it is needed? That a bigger, if anyone is new in the class, that is why I'm giving one prerequisite from the yesterday's class. Okay, because today's topic will be the continuation of the yesterday's class. So we can divide it into the sub modules. And this is a very basic. I have showed you that the input size is 48. That means input size means the number of gates here in this net list. So circuit design, that circuit number of gates is actually 48. Okay, and that circuit design, another name is net list. It is a good name of circuit design. And this is cut line. Okay, cut means that if it is partition 1, partition 2, and partition 3, then the number of lines going from P1 to P2 or P2 to P3 is known as cut. Cut 1, cut 2. So cut 1 is 1, 2, 3, and 4. You can see cut 2 is as well 4. And number of gate in those partitions are size. Okay. Next, the different levels of partitioning is being discussed. Problem, how to formulate a problem for partitioning is also discussed. What are the parameters we should keep in our mind? Next, the partitioning techniques I was actually discussing. So the 3 techniques, that is random selection, cluster growth, hierarchical clustering, that is the constructive techniques I have discussed. And today I will discuss the mean cut, the very much important topic. Okay, this is the most important topic from partitioning algorithm. You can mark it like a double star even. Okay, and simulated annealing as well, very much important. But today I will discuss mean cut algorithm. The random selection, the quality, performance, all are being discussed, and I will share this PPT with you as well. So not to worry. The hierarchical clustering technique is being discussed. Today I will start with this. I have given a very brief knowledge about KL partitioning, but today I will discuss it with an example. Fine. If you are having any question, any kind of queries, you can raise your hand, or you can just stop me and ask me, ma'am, I'm not getting this. And I will even give you a chance to ask me the question as well. So this is the two person, Carninghan and Lean, 2 people. You can see this journal, their journal. They have actually given this algorithm. It is one bisectioning algorithm. So it is a bipartition. So the input graph is partitioned into 2 subsets of equal size till the cut size keeps improving. And vertex pair is vertex pair which give the largest decrease in cut size are exchanged. These vertices are then locked. When it is exchanged once, then it will be locked. So just see, this is the algorithm, and I will discuss today the example. So this is one net list, fine, where you can see these gates are there, some NAND gate, NOR gate, or gate that this is not gate B. So we are just naming all the gates as node or vertex. That's A, B, C, D, E, F, G, H. Fine. So what is the number of vertex? It is 8. Okay. How they are just represented with a graph, that A is connected with C. Just follow my cursor. That is, A is connected with C, A is connected with E, C is connected with E. So A, C, A is connected with E, C is E. So this kind of representation is in the graph. And you can see some edges are thickened. Some edges are thickened and some are actually thin. The thin edges cost function. So you can take it like the thick edges are having cost of 1 and thin edges having cost of 0.5, because I have to calculate the cost in the next slide. So this is the next slide where we are actually calculating the cost, and I will discuss how we are calculating. So just randomly I have partitioned into 2 sets. So 8 vertices are there, 4 and 4. See, there are 4 vertices and there are 4 vertices. So this by partitioning is done randomly. You can choose any. That is why I am saying that many options are there. Okay. So A, B, D, and E are one side, and C, F, G, H are in one side. If we are partitioning the graph like this, then the connectivities are actually maintained and they are actually drawn. Then how many cut line are going by this partition? We have to calculate. How many cut line? 1, 2, 3, 4, 5, 6, 7. 7 number of cut lines are there. Now, by the algorithm, we have to check all the pairs gain. All the pairs gain. Now, the pairs are A. So, we have to check A with C, A with F, A with G, A with H. Fine. B with C, B with F, D with G, E with H. And so on. So, this AC pair, this EX minus IX is external edge, number of external edge minus number of internal edges. External edge means those edges crossing the cut line. So A is having how many edges crossing the cut line? It is 1, right? And that edge is, see, thin line. Thin line means it is having a cost of 0.5. That is why under EX it is written 0.5. Next, internal edge. How many internal edge A is having? Only 1. And that is again thin. So 0.5. So 0.5 minus 0.5. Okay. For C, so Y. Pair is X and Y. Here X is A and Y is C. Because we are checking between A and C. So Y, C is having external edge. How many? C. 1, 2, 3, 4. 4 edges. And those 4 edges, 3 are of thin line. That means 0.5, 0.5, 0.5, 1.5 plus 1 of thick line. 1. 1 plus 1.5, it is 2.5. So external edge for C is 2.5 minus, now I have to calculate the internal edge. How many internal edge? Only 1. That means 0.5. So 2.5 minus 0.5. Fine. Now the cost. The definition of cost is definition of cost of C or cut. You can say cut or cost between X and Y. Here X is A. In this case, X is A, Y is C. How we are calculating that? That is DA. If this value 0.5 minus 0.5 is equals to what? 0. 2.5 minus 0.5 is equals to what? 2. So that is DA and that is DB or DC for this C. DA plus DC minus 2C. 2C. That C is, if we are having a edge, then it is 1. If we don't have any edge, then it is 0. So do we have any edges between A and C? Yes. That means the value is 1. Okay. So we have to calculate, that is 0 plus 2, that is 2, minus 2 into 1. 2 minus 2. Okay. But in this case, we are having a thin edge. So 2 minus, that is 0.5 minus 0.5, 0. 2.5 minus 0.5 is 2, minus 2 into 0.5 is 1, because cost is what? It is present and it is a thin line. So 0.5. So gain is coming like 1. Now please tell me if you are having any kind from this set and taking A, and we are actually checking the pair for all these 4. Next, দেখো এই যে হরাইজন্টাল লাইনটার পরে বি এর সঙ্গে বাকি 4টে, তারপরে ডি এর সঙ্গে বাকি 4টে, ই এর সঙ্গে বাকি 4টে, যে কোনো একটা র্যান্ডমলি আমি তুলে আবার একটা এক্সপ্লেন করছি, তাহলে বুঝতে পারবে। ওকে, র্যান্ডমলি যে কোনোটা আমি তুলে এক্সপ্লেন করছি। সাপোজ তার পরেরটাই দেখো, এরটা আমরা অলরেডি উই হ্যাভ ক্যালকুলেটেড, সো ইট উইল বি সেম। তাই জন্য এখানে কিন্তু ক্যালকুলেশন বারবার করতে হয় না, রিক্যালকুলেশনের দরকার নেই। এফ এরটা কি হবে? এফ সি, চেক এফ। এফ এর সঙ্গে এক্সটার্নাল হাউ মেনি এজেস আর देयर ফর এক্সটার্নাল, তার মানে কতগুলো কাট করেছে দেখো, একটা থিন লাইন, একটা থিক লাইন আছে, একটা থিন লাইন আছে, রাইট? থিক লাইনটা 1 আর থিন লাইনটা কত? 0.5, তাই জন্য 1.5। এফ এর ইন্টারনাল কটা এজ আছে? only 1, and there is another 2, f to h একটা আছে, f to g একটা আছে, দুটো 0.5 মানে কত? আচ্ছা, আর একটা সি আছে। এফ এর সঙ্গে একটা দেখো জি আছে, 1 এজ, যেগুলো কাট লাইনকে কিন্তু ক্রস করেনি। একটা আছে জি, 1 is h, another is c, so 0.5 plus 0.5 plus 0.5, it is 1.5. then 1.5 minus 1.5, external minus internal, then d of f কত এলো? 0. so d of a is 0, d of f is 0, তাহলে কস্ট ফাংশন কত আসবে? 0 মাইনাস 2 ইন্টু এ আর এফ এর মধ্যে কি কোনো এজ আছে? নো, তাহলে 0। তাহলে গেইন ইজ দ্য ভ্যালু, এ ইজ সেম ফর অল দ্য থিং। বি এটা জাস্ট একবারই ক্যালকুলেট করছি, বাকিগুলো কিন্তু আমি জাস্ট লিখে দিচ্ছি। আবার এখানে যে সি পেয়ে গেছো, দ্যাট সি উইল বি অ্যাকচুয়ালি কপিড হিয়ার। এগুলো কিন্তু একবারই ক্যালকুলেট করা, জাস্ট কপি পেস্ট করা তারপর। বাট গেইনটা প্রতি টাইমে চেঞ্জ হচ্ছে, কারণ এই নিজেদের মধ্যে যে এজটা, whether it is existing or not, if it is existing then take the cost function, if it is thin line take 0.5, if it is thick line take 1. that is why এটা, কারণ এই কনস্ট্যান্টটা এই প্রবলেমে দেওয়া আছে, এটা একটু ডিফিকাল্ট প্রবলেম, আরো সহজ প্রবলেমই তোমাদের এক্সামে আসবে। I have actually chosen the difficult problem. দেন তোমরা যখন ছোট একটা গ্রাফ পাবে, সাপোজ 4টে ভার্টেক্সের, তোমাদের কাছে অনেক ইজি হয়ে যাবে। নেক্সট দেখছি আমি ফ্রম দিস অল, দিস এ গেইন ইজ দ্য হাইয়েস্ট। দেখো সমস্ত গেনের মধ্যে দিস পেয়ার ডি এন্ড সি ইজ দ্য গিভিং আস দ্য হাইয়েস্ট গেইন অফ 2. as it is giving the highest gain, so which one is giving us the highest gain? we have to exchange that, কারণ পয়েন্টে তাই বলা আছে। ওকে, জাস্ট এক্সচেঞ্জ, সেইটাকে এক্সচেঞ্জ করো। যেই এক্সচেঞ্জ হয়ে যাবে, কি করবে তার পরের পয়েন্টে? জাস্ট লকড দেম। তাহলে we have to exchange this c and d. so in the next slide I am just exchanging c and d. see, ফার্স্ট সেট যদি এটাকে ভাবি, সেট 1 এ আগে কিন্তু d ছিল, সেট 2 তে c ছিল, নাও সেট 1 is consisting c and set 2 is consisting d. so we have exchanged this c and d, and those two are locked, that is why they are shaded. okay, now as these two are locked, we have to calculate what? the pair for a with f, a with g, a with h. কি হলো? একটা রিডিউস হয়ে গেল ক্যালকুলেশন। now these calculations are not same, because দেখো এদের যে কানেক্টিভিটি গুলো কিন্তু এখন চেঞ্জ হয়ে গেছে। কারণ আগে ছিল 7টা, this cut line was having 7 edges, now it is having 1 2 3 4 and 5 edges only. so the mean cut, that is the cut line, that this partition is actually cutted with only 5 now, so it is being reduced. okay, Again, with the same way, we are calculating the pairs A with F, G, H, B with F, G, and H. C, we no need to do that because it is already being locked and it is exchanged already. And E with F, G, H. So it is one iterative type of algorithm, right? And after calculating this, we are getting all the negative gain. If the gain is negative, then it's good. So it's sorted already. And when it is the highest gain is offered by B and G, and it is coming like 0. So what we have to exchange now? B and G. The algorithm is asking us to just exchange B and G. So in the next slide, we are exchanging B and G, and we are locking them as well. So CD is being exchanged and locked. BG is exchanged and locked. Next, we have to calculate what? A to F, A to H, E to F, E to H, right? And after that, we are having two equal gains, -1, -1. আর দুটো দেখো -3, -2. কোনটাকে আমরা নেব? So again, I was asking you, telling you that it is optimization problem. That is why these problems are NP-complete problem. These are not These are not solved in polynomial time. Okay, these are NP-complete problem. So we can choose this one as well. This one. So it's upon the user because we are having more than one options. And এই জন্যই তোমার যেটা আনসার হবে তোমার ফ্রেন্ডের যে সেটাই আনসার হবে এরকম নাও হতে পারে। ওকে, সো বাট পার্টিশনিং এ কিন্তু মিন কাটই দেবে ফাইনালি অ্যালগরিদমটা, বাট স্টেপস ওয়াইজ আলাদা হতে পারে। সো সাপোজ উই আর চুজিং দিস ওয়ান, দেন A and F are actually exchanged and they are being locked. And for the last step, আর কারোর তো কোনো পেয়ারের সঙ্গে আমরা মানে গেইন ক্যালকুলেট করার নেই, বিকজ only two are left, two vertices are left out and those are actually swapped. But কি দেখতে পাচ্ছি, the second one, it is showing the mean cut was 7, this one is 5, but এটাই দেখো কটা হয়েছে 1 2 3 4 5 6, তাহলে বেড়ে গেল। এটাতে দেখো আরো বেড়ে গেছে 1 2 3 4 5 6 7 8, এটাতেও তাই অলমোস্ট 9। দেন এই অ্যালগরিদমটা কি হয়, অপটিমাইজড রেজাল্ট পেয়ে যাওয়ার পরেও রান করে। বেসিক্যালি এই যে রেজাল্ট আমি পেয়ে গেছি না, দিস ওয়ান ইজ দ্য বেস্ট রেজাল্ট, দিস ওয়ান ইজ দ্য অপটিমাইজড রেজাল্ট। সেটা আমরা কোন ইটারেশনে পেয়েছি? সেকেন্ড ইটারেশনেই অনলি পেয়ে গেছি, বাট স্টিল this one is going on and it is giving us result, but they are not optimized. Basically যখনই এইগুলো না পজিটিভ গেইন দেয় তখন এখানে এই অ্যালগরিদম গুলো অ্যাকচুয়ালি তখনও মানে ওটাকে আরো মিনিমাইজ করতে হবে, আর যখনই 0 দিয়ে দেয় দ্যাট মিনস ইট ইজ অলরেডি বিং মিনিমাইজড। 0 দেওয়ার মানে কি, গেনে কি -2 ইনটু কস্ট ফাংশন, তাদের নিজেদের মধ্যে এজ আছে কি নেই, নেই মানেই কত 0, তার মানে ওই ভ্যালুটাকে অ্যাকচুয়ালি কমিয়ে দিল। মাইনাস সামথিং যখনই করিয়ে দেওয়া তাহলে গেইনটাকে কমিয়ে দেয়। গেইন সবসময় নেগেটিভে বেটার। ফর মিন কাট অ্যালগরিদম অর KL অ্যালগরিদম, গেইন নেগেটিভ ইজ বেটার, and whenever you are getting any gain of positive value, that means you have to exchange that. Okay, so the final answer is, see, A, B, C and E in one partition, D, F, H, G in another partition. দেখো সেটা কোন স্লাইডে ছিল, জাস্ট সেকেন্ড ইটারেশনে A, B, C, E, D, F, G, H, A, B, C, E, D, F, G, H. সেখানে already we have actually reached with our optimized result, but still the sweep was there, or swap was there, and the iteration was going on. And this is actually the one of the drawback of this algorithm. The drawback is scale algorithm consider balanced partition only. কি করছে, প্রথমেই equal size এ biparts করছে, that bipartition is one drawback of this algorithm. আরেকটা যেটা বললাম that we have already reached to the final optimized output in the second iteration only, but still there doing that or running that algorithm up to number of 5 or 6 iteration. That is another it is actually increasing the time complexity of the system. So the time complexity is big O of n to the power cube. আমি তোমাদের বলেছিলাম big O of n is good, big O of log n is as well okay, but big O of n square, that means polynomial যখন এটা quadratic হয়ে যাচ্ছে or exponential, that is very bad, because exponentially increasing means exponential curve কিভাবে যায় like this, okay, একদম sharply. So that is not good. Okay, so that is one drawback. এটা লিখতে আসতে পারে এক্সামে, that drawbacks of KL algorithm. Another is very important, that is the KL algorithm considers ages instead of hyper ages. I hope you don't have that idea of hypergraphs. In graph theory, hypergraph is actually defined as those graphs where তোমরা কি জানো age হচ্ছে it is connecting two vertices. Age সবসময় দুটো vertex কে connect করে. No, this is not true. One edge can actually connect more than two vertices, and that graph is actually known as hypergraph in graph theory. Fine. কিভাবে সেগুলো actually define হয়? Suppose there are three vertices, elliptically একটা edge draw করা হয়, ওই তিনটেকে নিয়ে একটা বাউন্ডারির মতো elliptically draw করা হয়, and that is known as hypergraph, and that elliptical edge is known as hyper edge. So this algorithm actually fails for hyper edges. যদি এরকম কোনো প্রবলেম গিভেন থাকে, বিকজ একটা অ্যালগোরিদম, ইফ আই এম গিভিং ওয়ান অ্যালগোরিদম যেটা একটা জার্নালে পাবলিশ হচ্ছে, সেটা সবার জন্যই চলা উচিত, ওকে, রান করা উচিত। বাট here the drawback is scale algorithm consider করেছে only edges, যেটা কিনা দুটো vertex এর মধ্যে connected. If there are any high